Unity Water is proud to sponsor this podcast series because we believe great news, great solutions and great outcomes deserve to be shared. See what we're all about at unitywater.com. You're listening to the Australian Water Association's podcast series.
This is Hazel Flynn, and with me now is Alana Duncker, Senior Consultant Strategic Engineering at Stantec, and we're here to talk about a demand forecast tool that's been developed for SA Water. Thank you for coming in, Alana.
No problems, thanks for having me.
So tell me, this demand forecast tool, how important is it for SA Water's operations control group?
Well, it's quite important because when you're looking at operating and running a network, and it's a very large, complex, lots of flexibility in the network, they need to know how much water they have to supply, where it is and when it is. And so this demand forecast tool, it's really a short-term look ahead. It's looking at 7 days only, so it helps them in their production planning so they can manage how they're going to run their network, what do they need to produce at each of their water treatment plants, and then further upstream how they need to manage their bulk water to really optimise for cost, how they're going to run the network, but then also give their operators information about, what's coming up, what are the challenges are going to be, and how they need to manage their plans around that.
So what are the variables that go into that tool? Because there's a lot of things to take into account.
Yeah, so it's a climate-dependent demand forecast. So we're basically bringing in information from the Bureau of Meteorology, so the temperature forecast, maximum temperature, the rainfall forecast, and from that we can calculate a number of other parameters such as the soil moisture index and evaporation. We also take some of that information and lag it for the next couple of days before. So really the changes we've made, we've actually built this model of about 40 different parameters. They all come in every morning, go through this demand forecast tool and pump out a forecast for the next 7 days.
And I guess historical usage must be part of that too.
Yeah, so that's how we've really built the model. So we've gone, the tool itself at the moment is kind of trained over the last 3 years of data. So we've got historic weather, customer information, population data, day of the week, special events. That's the information that trains the model, plus the historic demand of what actually happened on those days, and that creates that relationship between, with these input variables, this is the demand we saw, so that when we put new information, forecast information through it, if the day is like this, what is the demand we're going to get out the other end?
So in terms of the enhancements and improvements over that time, is it mostly about that, mostly about training it into kind of finer abilities? So
our original demand forecast tool, we really only looked at 4 input parameters, the temperature, the rainfall, the soil moisture index and evaporation. And we really took the data in. It was trained in a similar way but used a different algorithm to do that, different regression model, and it was very much coded within the tool. So the users had been using it for 4 years and noticed, maybe it's not as accurate on some days as other days. There are input data that we want to test and trial, but we can't because we're not coders. So in the last 4 years, there's a lot of new software on the market. And so the main change was to take the underlying essence of that demand forecasting tool and what it's doing and what the inputs are, but to put it in a different platform so that we can trial different regression algorithms. We've got the flexibility to put in more input parameters such as lagging the temperature data or the rainfall data, or putting in yesterday's demands, or all sorts of parameters, and they can then test and trial that to achieve a better kind of match in that model. And the users now have the flexibility to do that without having to be software programmers and get into the code to do that.
That's ideal, isn't it?
Yeah. That was their main driver. They just wanted the flexibility to be able to take it and run and implement these improvements or test things that they'd seen over the last few years. And then also be able to then take that and expand it to other geographic regions as well. So again, without having to go into the original platform and code a new model, this new Azure machine learning platform lets you build as many models as you like. And so you can train each of them individually, so you've got different characteristics for Metro Adelaide compared to the characteristics of our southern kind of more coastal holiday areas.
And what was the University of Adelaide's involvement?
So they had been running a long-term study for household water use. So our demand forecast tool, it does this overall forecast of what total Adelaide demand is, but then we break it down to the customer level. And so because they had done this study, they had smart meters for 150 customers within the metropolitan Adelaide area that they'd been monitoring for 3 years. Fine interval data. So from that you can see the trends of, different water use patterns over a day. And so within our forecast tool at the moment, it takes the forecast, breaks that down, and we define, the 24-hour pattern is a standard kind of residential pattern. This data from the Adelaide Uni allowed us to look at what is actually happening over the last 3 years and look at, okay, here are some seasonal differences, because, you've got theoretical curves, and what's right for Melbourne and Sydney may not be right for Adelaide. So if we've got this rich data source of 3 years of continuous water use data and 24-hour patterns for everybody in this sample set, why wouldn't we use that? And so we're able to then take that and input that into our demand forecasting. So we're using patterns for each season, for each kind of demographic as well, and each region that's relevant for our city.
Invaluable.
Yes.
And a modelling and a modelling tool is only ever as good as its performance record. Mm-hmm. So you actually developed accuracy parameters to see how well the demands match the reality. What did they show?
Well, sometimes it's better than others. So the key there was, we'd been running this demand forecast tool for a long time, and basically we're tracking, this is what we're forecasting and this is what the actuals were. But for the user, they're just seeing lines on a chart, or they're seeing how good the model matches. What they really wanted to see is real numbers, because we're presenting this information up in a bunch of dashboards for the operations team. So they're interested in, okay, what's my actual megalitre per day difference? What's my percentage difference? How have I tracked today versus the entire month? Is there a long-term drift or a trend going on? So it's really about, they're not, super complex accuracy parameters. It's just comparing what we forecast, what we would have forecast if we had the actual weather, because sometimes the difference is there. It's not our problem, it's the weather forecast. What the difference is there in terms of how many megalitres per day, and what's the percentage of that out of the total, volume of water that we're actually delivering. And then breaking that down further, so we're comparing not just Metro Adelaide, but once we break down our forecast, what's the differences between what we've forecasted for each treatment plant versus what actually happened, with the aim of just presenting that information that's easy to use and easy to interpret, so that they can go back and say, okay, there are some improvements that we can make still. Let's recalibrate our model again. Let's go and look at, this particular area is always 10% low. Why? Oh, there's some missing customers or something like that, or we haven't assumed the right kind of scaling for, our residential customers are very thirsty in that area, and so when it's hot they go crazy. We're in another area, they don't want to water their gardens, so we need to split and divide our system a little bit finer to get better accuracy.
So every bit of feedback you get is an opportunity to fine-tune the tool.
Yes, exactly. And so I think the intention of these tools was to have a tool that would be used live and modified live and accessed by our users. So some of the tools are very easy for them to get in and make changes and, adjust things, recalibrate things, or test and trial different areas. The demand forecasting tool was a bit more of a challenge, and this new project has really pulled that out into a format and a platform that's much easier for the users to then go and make this continuous improvement.
So they're obviously very happy. I mean, you must have had a great response from SA Water.
It's good. And, there's a lot of case studies that have come out of the work that they've been doing earlier this year. It's very hot in Adelaide. They had challenges with water supply. They ran this demand forecasting tool and could see, over the long weekend, we're going to have 4 very hot days. It's going to get hotter and hotter and hotter. There are limited capacities at some of those treatment plants. How did they need to change their operating plan? So it was invaluable for them, because they knew exactly that they needed to switch the way that they operated. They needed to plan a little bit differently. And so that, the more confidence you have in your planning, because the underlying tool has given you good data that is accurate, or is accurate within whatever percentage that you can measure, you can make better decisions, more confident decisions, and maybe run your system a little bit harder, or know where you need to spend the money or to make it, really operate well.
And where to from here? Do you continue to be involved in developing the tool?
It's so this particular expansion project is now finished, and this enhancements to the demand forecasting tool, but there's always work to be done. So one of the other tools that we developed was an optimization tool for the bulk water network. And so that was very much focused again on the Metro Adelaide area. So we are currently starting to look at expanding that to the northern regions of Adelaide, so not even Adelaide, like further north than Adelaide, so our Morgan to Whyalla system, and seeing what opportunities there are there for bringing that into our platform for the optimisation tool, but also other opportunities around what do they need in terms of decision support tools. So is there demand forecasting need? Is there live hydraulic modelling needs that will help them manage outages or plan for different scenarios? So they have a tool that they can go and run and test things on the fly as events happen, rather than having to go to a manual of standard operating procedures that's out of date. It's 20 years old, and they don't trust that. They need a model that's live, or information that's readily available to help them make better decisions.
So lots of good tools coming SA Water's way, and lots to keep you on your toes.
Yes.
Thank you so much for coming in and
No
talking about it
problems.
with us, Alana. And that was Alana Duncker, Senior Consultant Strategic Engineering for Stantec. Thank you for joining us.